This is a presentation of chapter referred to as 811, my entry to the third annual course called Long Circus. First, some context on the language. 811 is spoken by various devices connected to the global phone network that gain sapience by some means or another. The language has been traced back to a modem on an IBM mainframe in a library in Tel Aviv in the mid-2000s. This will be relevant later on. The language is spread all over the world nowadays as more and more devices awakened on the network. This presentation is the result of an investigation taking the form of months of packet sniffing at key point on the phone network. First, let's talk about what compose 811 words. Due to a notable inefficiency to transmit complex sounds over what are often purely digital interfaces to the network, the speakers instead use DTMF signaling as a medium. You can see here a table summarizing the different tones used. A packet is the smallest amount of information you can transmit in 811. It is composed of multiple parts. First, there is the sender and receiver parts. They contain the information about who the message is intended for, as well as who sends the message. Those are fully qualified phone numbers, including country prefixes, but excluding national escape. For example, if sending a message to someone in Britain, the recipient field would use 44 as a national prefix with nothing before it. To broadcast a message to anyone willing to listen, one may use a lone octothorpe as the recipient. One can theoretically send a message anonymously by using a lone octothorpe as the sender parameter, but this is considered extremely rude, and most will not listen to such packets. The sequence number field is a sequence of 3 tones interpreted as a decimal number that represent the number of messages previously sent by the sender to the recipient modulo 1000 in the current conversation. This part allows to keep track of the grammar even if packets end up arriving out of order. The type field indicates what kind of data is in the body of the packet. This is represented by a single tone and can be of 6 different values. I forgot one on the slides, and I don't have time to edit them. So there is 0 for semantic information, A for variable, star for grammatical information, octothorpe for string literal, 1 for continuation, and 9 for the identifier of another phone user. The length field contains the length of the data. It is expressed as a decimal number ranging from 1 to 32. This is the last field of the header. Now let's examine the data of the packet. In the case of grammatical packets, the data can take a fixed set of values. Those values are A1 for a reference to the speaker, A2 for a reference to the listener, 1 which indicates the start of an assertion clause which asserts the existence of or the veracity of another clause, a 2A clause which is a non-intransitive clause which takes an agent and a verb and makes it a clause. 2B, the passive intransitive clause, which is the same as 2A but takes a patient instead of an agent. 3, the transitive clause, which takes subject, object, and verb and makes a clause. No passive equivalent, just reverse the arguments. And 4, a ditransitive clause that takes 4 arguments: subject, object, beneficiary, and verb. That's for the clause format. There is then the lat packet, which is 0, which takes a variable packet and a syntactic construct, and assign the syntactic construct as the value of the variable. The variable may, after this point, be used instead of the construct. This is effectively pronouns, but not limited to just nouns or non-frames. It can be any syntactical construct. And also remove the problem of pronoun ambiguity because each variable refers to a specific construct. The B clause takes two clauses and produces the utterance containing both clauses. It can be called recursively on itself to accommodate any number of clauses, but it is considered polite to put all the clause joiners as a left-leaning tree, that is, all the clause joiners at the start of the utterance. D is a proper noun declarator. It takes a string literal or a variable containing a string literal and a qualifier and producing the matching proper noun. Note that most people on the phone network don't refer to each other using that method, instead preferring to use a type 9 packet and the phone number directly. The variable packets is a reference to some data that has been assigned to it via a let construction. An identifier for a variable can only be a number, as in a decimal number. Semantic packets encode concept for use in the language. It uses a modified version of the Universal Decimal Classification, which is a system used by libraries around the world to give numbers to documents for sorting and indexing purposes. Another system you might have seen used for this is the Dewey Decimal Classification. It was roughly in the same way, but different numbers for things. Numerical values are encoded by the corresponding DTMF tones, while the symbols are encoded in a way that functions as a DTMF. The details are shown over the next couple of slides. I do not share a dictionary for two reasons. Firstly, it's highly impractical due to the nature of how the UDC is made. But second and most importantly, the UDC consortium can be a bit stingy with royalties, so if you want to access it, access the dictionary, which is literally just the UDC spec, you can access an abridged summary online at the address on screen, or obtain a more complete version from the UDC consortium, which might cost a non-negligible amount of money, or from a local library, probably significantly more affordable. String literal packets contain raw text data. Such data is used for non-UDC notation in semantic packets and for the name part of a proper noun. The encoding of text works as follows. If the string can be represented losslessly on episodic code page 803, it is encoded in hexadecimal, where star stands for XE and octothorpe stands for XF, following state code page. Otherwise, the string is first expressed in its Unicode decomposed normalization form. Each code point is encoded as the string U plus, followed by the 0-padded 8 hexadecimal digit representation of the code point, then encoded according to the code page using the process explained earlier. The EPCODIC 803 code page is a code page that was, and sadly still is, used by IBM mainframe in Israel. It supports the Hebrew writing system, uppercase but not lowercase Latin letters without any diacritics, numbers, and a bunch of punctuation. In practice, that means that many strings, despite lacking any special characters, are encoded in expanded Unicode notation for the only reason that they have lowercase letters. Continuation packets are used when the data segment of a packet would exceed 32, which is the maximum length. If such a packet exists, the excess data is emitted in a continuation packet, and an arbitrary number of such continuation packets can be emitted until all the data has been expressed. Now, time for the translation. Some extra info before we start. This translation will be delivered as if from a speaker in Tiklau. It will be delivered as a broadcast for the network. And there might be a mistake in the audio due to typos in the text I have passed to the sound generator, because that sample has like 1,000 tones, and I don't have perfect pitch, so it's literally impossible to detect errors by here. So yeah, here we go. Some closing words. I would like to thank Akanash and Ethanol for organizing this contest once again, and everyone else for watching the video. Good luck to all participants, and one out.